In this video, we would be doing from question number 13 onwards for exercise 1A, force. The previous questions have been done in few videos, the link for which will be there in the description below. Consider watching them and do share the videos with your friends. So let us start with the 13th question. A physical balance has its arms of length 60 centimeter and 40 centimeter. So we have this as 60 centimeter and this as 40 centimeter. What weight kept on the pan of the longer arm will balance an object of weight 100-gram force kept on the other pan? So we have an object which weighs 100-gram force. So this is kept here on the shorter arm. So the shorter arm is 40 centimeters. We need to find what weight here would balance the beam. So it is pretty simple. What we have to do is we have to equate the moments on both sides. That is, the anti-clockwise moment should be equal to the clockwise moment. And that's what we're going to do. So here we can see that I have written x into 60, which is nothing but force, that is xgf, into 60, that is perpendicular distance, is equal to 100 gf, so this is the force, into perpendicular distance, which happens to be 40. So here what I get is x is equal to 100 into 40 divided by 60. So I get the value of x as 66.67 gf, gram force. So this was a pretty easy question. Coming to the next question, that is the 14th question of exercise 1A. The diagram shows a uniform meter rule weighing 100 gf. So the entire length of it is 1 meter, which is nothing but 100 centimeters. Pivoted at its center row, so it is pivoted at the 50 centimeter mark. Two weighs 150 gf. So here we have 150 gram force and 250 gram force. So there is 250 gram force. Hang from the points A and B respectively. So this is the point A and this is the point B. So from A and B they hang such that OA is 40 centimeters. So this distance is given as 40 centimeters and OB is 20 centimeters. So this distance is given as 20 centimeters. Calculate first one, total anti-clockwise moment about O. So for finding the anti-clockwise moment, we would be doing force, that is 150 into perpendicular distance, that happens to be 40. So 150 into 40 gives us the total anti-clockwise moment. So that happens to be 6000 gram force centimeter. We will keep it in gram force centimeters since the textbook answer is also there in gram force centimeters. So coming to the next one, total clockwise moment about O. So for finding the clockwise moment, we would be finding the moment of this force about the point O. So that's again going to be force into perpendicular distance. So force happens to be 250 into perpendicular distance, that happens to be 20. So 250 into 20 gives me 5000 gram force centimeter. Now next we need to find the difference of clockwise and anti-clockwise. So before finding that, we would first decide which is greater out of 6000 and 5000. Definitely 6000 is greater. That means the anti-clockwise moment is greater than the clockwise moment. So when we find the difference, we would just be subtracting the clockwise moment from the anti-clockwise moment. That gives us 6000 minus 5000. That gives us 1000 gram force centimeter. And the direction we have to write of the moment which was greater. So here in this case 6000 gram force centimeter was greater. So I write it as anti-clockwise because this had anti-clockwise direction. Now the fourth part of the question, the distance from O where 100 GF weight should be placed to balance the meter rule. Now, as we can see here, the anti-clockwise moment, that is 6000 gram per centimeter, is more than the clockwise moment here, that is 5000 gram per centimeter. That means this side, that is the left side, is heavier than the right side. So it is definite that we have to add the weight on the right side because left side is already heavier. If we add the extra weight of 100 GF on the left side, it becomes even more heavier and it will never be balanced. So in order to balance this rule, what we have to do is we have to add the weight on the right side. So what I do is I equate the moments and we do not know the distance, so we have to find the distance. So I take the distance as x. So what I do is here anti-clockwise moment, I write it as 150 into 40. So we get it as 150 into 40 is equal to clockwise moment. So clockwise moment we already know one is 250 into 20 and another one is because of the 100 GF force. So I add that. So I added 100 into x, where x is the distance of the force. Let's assume it is somewhere here where the mouse is. So this distance will be x. So 150 into 40 gives me 6000 and 250 into 20 gives me 5000. I take this 5000 to the other side, I get 6000 minus 5000 and this 100 comes to the denominator, so that becomes 6000 minus 5000 divided by 100. 0 cancels, so that is 600. 6000 minus 5000 is 1000, so 1000 divided by 100, so 0 cancels and we get it 10 centimeters. So it would be placed at 10 centimeters somewhere here on the right side because right side was lighter than the left side. So getting into the 15th question, exercise 1A, force. A uniform meter rule of weight 10 GF. So the weight of the meter rule is 10 GF is pivoted at its 0 mark. So it is pivoted here. What moment of force depresses the rule? So we need to find out what is the moment of the force that depresses the rule and how can it be made horizontal by applying a least force. So we need to find out, what will be the least force required to keep it horizontal. So for finding what moment of force depresses the rule, now we already know that from the previous questions of this exercise itself, that the weight of the meter rule always acts on the center. So the weight is 10 GF and it would be acting at the 50 centimeter mark because it is a uniform meter rule. Meter rule means it has 100 centimeters. So it would be acting on the 50 centimeter mark. So 10 GF would be acting in the 50 centimeter mark. So the perpendicular distance of this force is going to be 50 and the force is 10 GF. So if we find the moment of force, it happens to be 10, that is this force, into perpendicular distance, that happens to be 50. So 10 into 50 gives me 500 gram force centimeter. Now, this is the answer for the first part. Now getting into the second part, see, in order to get the lowest force, we have to place the weight at the maximum distance. So the weight has to be placed at the maximum distance. So that is at the end here. Now, in order to balance it, I will write moment of force clockwise is equal to moment of force anti-clockwise. So there will be this force which will be rotating it clockwise and there will be this force which has to rotate it anti-clockwise in order to balance it. So for this force, we already know it is 10 GF and at a distance of 50 centimeters. So I write it as 10 into 50 is equal to, now here is the trick for this question. We have to assume the force as x and it has to be at the end because when you maximize the distance, the moment also maximizes. So here x into 100, 100 goes to the other side becomes divided by 100, 0, 0 cancels, and we get x is equal to 5 gram force. This will not be centimeter, it is going to be only gram force because it is not moment, it is the force. By mistake, I have written it as gram force centimeter. So for least force, it has to be at maximum distance. So this is the trick for this question. So the answer is 5 gram force and not 5 gram force centimeter. So getting into the 16th question of exercise 1A, a uniform half meter rule can be balanced at the 29 centimeter mark. So it is a half meter rule, that means the length of the rule is 50 centimeters. And it can be balanced at 29 centimeter mark. So here you can see I have marked fulcrum at 29 centimeters. When a mass of 20 gram is hung from one end. Now we need to see one thing here, which end is longer. So as we can see, 29 is slightly towards the right side. That means the left side end is longer. If it was 25 centimeter, it would have been exactly at the center. But here it is at 29 centimeter. That means the left side is heavier than the right side. So it is definite that the 20 gram mass is hung from the right side and not from the left side. So you can see here I have marked the 20 gram on the right side because right side was lighter than the left side. Now find the mass of the half meter rule. So we have already drawn the diagram. So for finding the mass of the half meter rule, we have to understand one thing here, that the mass always acts in the center. So here what happens is anti-clockwise moment is equal to clockwise moment. So clockwise moment will be because of this, that is 20 gram into the perpendicular distance. So that happens to be 50 minus 29. So that is 21. So that is how I get this 20 into 21. And here what I get is force, that is x, into perpendicular distance, that happens to be 29 minus 25, that is 4. Because we need to find this distance here, this small distance here we need to find, that happens to be 4. So this 4 goes to the other side, 4 into 5 is 20, 5 into 21 is 105 gram. So that is the mass of the rule. So from the 17th question onwards, it will be there in the next video as this was becoming very long. We would continue in the next video, the link for which will be there in the description. Do share the video with your friends. Dhanyavad.